So problem number 6. We want to find the derivative of the function y equals tangent 4a theta squared. So the way it's written like so. The chain rule and probably going to have to use the chain rule like twice. We have a composition here. You can say that y equals let's do f composition g composition h of theta. Okay? Or if we want to do a nested notation, then it will be f of g of h of theta, like so. So that's what the circle notation is advantageous when it comes to a composition of more than two functions. Now, if we work from inside out, inside will have 4 theta, so inside out h of theta will be 4 theta. The next one is g, so g of h will be tangent h. Okay, tangent 4 theta is tangent 8. And finally, f of g will be g squared, right? Take the tangent of 4 theta and square it. And then now we'll do the derivative. So the derivative of dh d theta, actually I can use the prime notation here. H prime of theta, like so, will be simply 4, and dg dh, or I can write it as g prime of h. Well, the derivative of the tangent is the secant squared, so the secant squared of h. And finally, df dg, or f prime of g, if you prefer the prime notation, will be simply 2g. All right, so we have now all the components. Let's write underneath here. I left room to show you the chain rule, a multi-stage chain rule. We're going to say that dy d theta, or I can write it as y prime, but theta is the variable of differentiation. Then we are looking at f of g of h of theta. I should have put parentheses right here. Sorry about that. So by the chain rule, it will be f prime of g times g prime of h times h prime of theta. Okay, so I have these two products to multiply each other, and I produce all three right there. So going back and say dy d theta, again I'm using this morning dual notation here, y prime of theta, f prime of g is 2g times g prime of h, secant squared of h, and then h prime of theta is simply 4. And now we need to spell it out. So we have 4 up front, 2g. Well, going back in g, the definition of g is tangent. So it would be 2 times tangent of h, which is tangent of 4 theta. And then we have the secant squared of h, but h is 4 theta, so times the secant squared of h, or the secant square of 4 theta. Okay? So you have 4 times like so. And then multiply it out, you have 8 tangent 4 theta secant squared 4 theta. I don't know about you, but I'm happy with this solution. And since I had a couple of questions from students, then I will send you an email telling you that provide your answers in terms of tangent and secant only, because somebody said, well, Aaron instructed someone to write the solution in terms of sine and cosine, but I did no such thing. I mean, even though it's normally good advice, it's good advice when you verify trigonometric identities, but in this case there was absolutely no need for that.